In this video, which is notes number 38, we're going to go over some of the log properties that we need. And in order to keep this video short, I'm not going to prove these properties in this video, but I will give you an optional video that shows you the proofs. So you decide if you're going to watch that optional video or not. Okay, we have 4 properties we're going to look at today. The first 2 are called the product property and the quotient property. And basically they tell you how you can use logarithms to split up or combine an expression. So number 1 says log base n of a times b equals log base n of a plus, not times, but plus log base n of b. So we have a product, a times b, but it splits up into a sum of logarithms. So that one is derived from an exponent property where you have a to the n times a to the m equals a to the n plus m. So you have a product of things, but you end up with a sum involved. So that's just kind of a preview of the proof. The second property is called the quotient property. So we have a quotient, we have log base n of a over b, there's our quotient, and that's equivalent to log base n of a, the numerator, minus log base n of b, the denominator. So what we're going to do is spend our time going through examples. And notice I put the product property and the quotient property at the top as reminders. And we're going to use those properties to expand each expression here in examples 1 through 4. So number 1, we have the natural log of 7 times x. 7 times x is a product, so we're going to use the product property, and we're going to break this up into the natural log of 7 plus the natural log of x. Now, you don't necessarily have to put parentheses around the 7 and around the x. It's the same thing without the parentheses. Okay, number 2 is log of 6y. So we could break that down using the same property into log of 6 plus log of y. Now you might argue, sorry, my y got kind of separated there. I didn't mean for it to be that far away. Okay, you might argue, well, why don't we break down log of 6? 6 is a product as well. You certainly can. You can break it down into log of 2 plus log of 3, since 2 times 3 is 6, plus log of y. I would say you don't have to break it down unless you're in the situation where you have a base which is a factor of your argument. So 10, the base, is not a factor of 6, so we didn't have to break it down, but you'll see in number 3 that we will. Okay, number 3, log base 4 of 16 over m. Notice we have a quotient, so we're going to use the quotient property from up above, and we're going to break this down into a log minus a log. So it's going to be the log of the numerator, log base 4 of 16, minus the log of the denominator, log base 4 of m. Now we know that log base 4 of 16 means the power that you would raise 4 to get 16. So 4 to what power is 16? 4 to the second power is 16. So this is equivalent to 2 minus log base 4 of m. And then number 4. It's also the log of a quotient. So let's break down the quotient. And we have log base 3. Actually, you know what? I'm going to back up a minute, because I'm going to take that quotient and I'm going to reduce it first. 6 over 3 reduces. So we have actually log base 3 of 2p over t. Now I'm going to break it down using the quotient property. So we have log base 3 of the numerator, 2p, minus log base 3 of the denominator, t. Now notice that 2p is a product. So we're also going to use the product property and break this into a log plus a log. So we have log base 3 of 2 plus log base 3 of p minus log base 3 of t. Now if I hadn't reduced the 3 over t, or excuse me, the 6 over 3, eventually it would simplify to be the same answer if you realized you needed to simplify. Because if I hadn't reduced it, I would have had a log base 3 of 6 plus a log base 3 of p minus a log base 3 of 3 minus a log base 3 of t. See, the ones on the top we would have added and the ones on the bottom we would have subtracted because of the quotient property. And then we could break down log base 3 of 6. Since 6 is a product, it breaks down into log base 3 of 3 plus log base 3 of 2, since 3 times 2 is 6, and we would have all the rest of it. And we would be able to cancel log base 3 of 3 with minus log base 3 of 3, and the answer would be the same. Okay, we're going to use those same two properties, but now we're going to use them to condense each expression. So number 5 is a log plus a log. So look back at the product property. If you have a log plus a log, notice you have to have the same base, of course. So you're going to change it to the log of the product. So this is going to be the natural log of the product, 3f. And then number 6, we have a log minus a log, same base, both base 10, common log. So this is going to be using the quotient property, and we're going to change it into the log of the quotient, b over 2. And then number 7 is going to combine both properties. So we have some logs that are added, we have some logs that are subtracted. Even the one in the beginning, you can think of it as being subtracted because of the negative sign. So any log that's subtracted is going to become the denominator of a quotient, and any log that's added is going to become the numerator. So altogether, notice they're all log base 5. If I was to do this in one step, I would have log base 5 of x times y, those were the positive ones, over 7 times 4, those were the negative ones. And then I'm just going to write this as log base 5 of xy over 28. You don't have to do it all in one step like that. You can do it in multiple steps, but you're going to get to the same thing. Okay, number 8. Notice that we have, 1, 2, 3, 4, 5 different logarithms, and they're all added together. And so because they're all added, we're just using the product property, not the quotient property. We don't have any subtracted logarithms. So that means we're going to be multiplying all these things, C-A-B-I-N. So we have log base C of C times A times B times I times N. We have, do you see what we have, everybody? We have, oh, that doesn't look very good. We have a log cabin by the sea. By the sea, haha. This is where I need a sound effect laughter. I forgot to cue my sound effects, sorry. Okay, now I said we were going to have 4 properties, and so far we've had 2. So here's the idea behind the third property. This is not the proof, this is just kind of to convince you about it. So let's say we had the natural log of 8 to the 4th power. Wouldn't you agree that you could write a to the 4th power as 8 times 8 times 8 times 8? Now notice that that is a product. So if you were to apply the product property, you could you could expand this into natural log of 8 plus natural log of 8 plus natural log of 8 plus natural log of 8. So how many natural log of 8s do we have? We have 4 of them. So this is equivalent to 4 natural log of 8. So notice that if we put these two sides together, the natural log of 8 to the 4th is the same thing as 4 natural log of 8. It's as though this exponent comes down and becomes just a multiplier. So that leads us to our third property, which is known as the power property. In general, if you have log base n of a to the b power, that exponent b comes down and becomes a multiplier, and you have b times log base n of a. Kind of looks like blog. But keep in mind, it doesn't matter what letters I'm using here. Just because I happen to be using n and a and b makes no difference. You could be using P and Q and R or whatever. So what I want to do now is incorporate that third property, that power property, in with the other 2 properties to simplify some more complicated expressions. So these first 2 here, we're going to expand. Okay, so number 9, we have the log of a quotient. So now we're going to start with the quotient property and break it into a log minus a log. However, notice that inside the numerator, there's a product. So we're going to break those up into a log plus a log plus a log. Notice in the denominator, there's a product. So that's going to break down into a log plus a log. Also notice we have some exponents. So we have a lot of things we're going to do. I think the wisest thing to do is to reduce 100 over 4. So why don't we rewrite the expression as log base 5 of 25 x squared y cubed over, and then instead of square root z, I'm going to write that as z to the 1/2 power. If we change radicals into exponents, we can use our power property. Okay, so I'm going to break this down into 4 logarithms. Anything that's in the numerator is going to be an added logarithm, and anything that's in the denominator is going to be a subtracted logarithm because of the same reasoning we used back here on problem number 7. So this one's going to look like log base 5 of 25 plus log base 5 of x squared plus log base 5 of y cubed minus log base 5 of z to the 1/2 power. Now let's use that power property. And log base 5 of 25 we know is 2. 5 squared is 25. We can take this 2 exponent and bring it out to the front as a multiplier. We can take this 3 and bring it out to the front of its log as a multiplier, and the 1/2 bring it out to the front of its log as a multiplier. So we have 2 plus 2 log base 5 of x plus 3 log base 5 of y minus 1/2 log base 5 of z. Okay, so there's our expanded expression. So we're going to see when we get to equation solving that there are times when an expanded expression is good and there are times when a condensed expression is good. So it's good to be able to go back and forth either way. Okay, problem number 10. What I'm going to do to start this one is to change my radical into an exponent. So this is the same thing as the log of 80a b to the 5th over c d cubed all to the 1/3 power. So all of them are to the 1/3 power. So for this problem, the first property I want to use is the power property and bring the 1/3 out to the front of the logarithm. So we have 1/3 times the log of that entire thing, 80a b to the 5th over c d to the 3rd. How many logarithms is this going to split up into? Let's see, we have 80, that'll be a log. We have a, we have b to the 5th, we have c, we have d to the 3rd. So it seems like it's going to break down into at least 5 logarithms. And what's the base in this problem? If it says log, it means log base 10, the common base. And since 10 is a factor of 80, we're actually going to break down the 80 as well. So this is going to be 1/3 times the log of 10. I'm going to put the 1/3 in front of everything. 1/3 times the quantity, log of 10 plus log of 8, because the 8 times 10 gives you 80, plus log of a, plus, now I'm going to bring that 5 out to the front using the power property, 5 log of b, going to run out of room, minus, because of the denominator, log of c, minus, and then the d is cubed. Notice it's not c cubed, it's just d cubed. So the 3 that I'm going to bring down only goes in front of the logarithm that has d in it. Same with the 5, it was only b that was to the 5th, it wasn't a. So only the 5 in front of the b. Now, what can we do with that? Well, we can write log of 10 as 1 because 10 to the 1st power is 10. So this part here becomes a 1. And if we want to, we can distribute the 1/3 among all of the logarithms. I would call that optional, really. So let's say we have 1/3 times 1 plus log, whoops, forgot my 1/3. 1/3 log of 8. Now, if you wanted to simplify that even more and you brought the 1/3 back up and made it a power, we already know that 8 to the 1/3 is 2, because the cube root of 8 is 2. So that whole expression could be log of 2. So 1/3 plus log of 2, if you wanted. I wouldn't care if you left it as 1/3 log of 8 or if you changed it to log of 2. Just want to show you some options. And then we have 1/3 log of a plus 5/3 log of b minus 1/3 log of c. And then we would have the 1/3 times the 3, so just minus log of d. So that would be our answer. And as I said, there are a couple of different forms you could write that in. You don't necessarily have to distribute your 1/3. Okay, now we're going to condense these next two problems using all three properties. So the first thing we would do is, if you have a number in the front, you would bring it up and make it an exponent. So that would be using the power property. So -4 comes up and becomes a power, or just the 4 if you want to leave the negative in front. How about if I leave the negative in front and I just bring the 4? Three comes up and becomes a power, and 2 comes up and becomes a power. And then any logarithm that's negative, that one's going to become part of the denominator, and any logarithm that's positive, that one's going to become part of the numerator, which means we have the natural log of, so the only one that's positive is this one, so we have 3x squared quantity squared, and then the denominator would be 2x to the 4th times 2y cubed. Okay, there's still a lot of work to do there. Let's go ahead and square the top. So we have the natural log of 9x to the 4th. Let's raise the bottom factors to the 4th and the 3rd. So we have 16x to the 4th times 8y cubed. And then we can cancel those x to the 4ths. And we can multiply the 16 and the 8 together. So we have natural log of 9 over 16 times 8 is 128. So natural log of 9 over 128 y cubed. And then 12. Same idea. We're going to start by taking the number in the front and raising it, making it a power on the argument. And if it's a 1/2 power, you're going to think of it as a square root. So these are all log base k. So we have log base k of, now any logarithm that's positive, its argument goes on the top, and any logarithm that's negative, its argument goes on the bottom. So we have 2 to the 6th on the top, we have square root of m on the top, and then we have k to the 5th power on the bottom. Is there anything we can do to that? Well, let's see, what's 2 to the 6th power? 64. So we could write this as log base k of 64 square root m over k to the 5th power. And then last thing today, we have our fourth property, which is called the change of base formula. And I talked about it a little bit before. So if you have something like log base m of n, let's say. I talked about this last time when we were using our calculators, and I mentioned that if you don't have the ability to do something like log base 2 on your calculator, you can do it a different way. So that was using the change of base formula. Log base m of n is equivalent to log base a of n over log base a of m, where a is whatever base you choose, and then see the n from the argument goes to the top logarithm, and the m from the base is now the argument of the bottom logarithm. So this would be, for example, it could be natural log of n over natural log of m. It could be log base 10 of n over log base 10 of m, or any base you want. Log base 97 of n over log base 97 of m. It doesn't matter. So let's use the change of base formula to find 3 equivalent expressions for log base 3 of 16. So it could be log base 10 of 16 over log base 10 of 3. It could be natural log of 16 over natural log of 3. It could be whatever base you want. Log base 1035 of 16 over log base 1035 of 3. If you put those in your calculator, you will see you get the same thing every time. Okay, here's your assignment, and most of these go fairly quickly. So you just need a lot of practice with using those properties to combine and expand expressions. Thanks, everybody.